What is magnetic field? The region around a magnet where the force of attraction or repulsion can be detected is called magnetic field. Magnetic field around a magnet can be detected by using a magnetic compass. Force of a current-carrying conductor in a magnetic field. An electric current flowing through a conductor produces a magnetic field. The field so produced exerts a force on a magnet placed in the vicinity of the conductor. French scientist André-Marie Ampère (1775–1836) suggested that the magnet must also exert an equal and opposite force on the current-carrying conductor. A current-carrying rod, Abe, experiences a force perpendicular to its length in the magnetic field. The displacement of the rod suggests that a force is exerted on the current-carrying aluminum rod when it is placed in a magnetic field. It also suggests that the direction of force is also reversed when the direction of current through the conductor is reversed. Now change the direction of field to vertically downwards by interchanging the two poles of the magnet. It is once again observed that the direction of force acting on the current-carrying rod gets reversed. It shows that the direction of the force on the conductor depends upon the direction of current and the direction of the magnetic field. Experiments have shown that the displacement of the rod is largest, or the magnitude of the force is the highest, when the direction of current is at right angles to the direction of the magnetic field. In such a condition we can use a simple rule to find the direction of the force on the conductor, the direction of the current and that of the magnetic field perpendicular to each other, and found that the force is perpendicular to both of them. The three directions can be illustrated through a simple rule, called Fleming's left-hand rule. According to this rule, stretch the thumb, forefinger and middle finger of your left hand such that they are mutually perpendicular. If the first finger points in the direction of magnetic field and the second finger in the direction of current, then the thumb will point in the direction of motion or the force acting on the conductor. Magnetism in medicine: when we touch something, our nerves carry an electric impulse to the muscles we need to use. This impulse produces a temporary magnetic field. These fields are very weak and are about 1/1000th of the Earth's magnetic field. Two main organs in the human body where the magnetic field produced is significant are the heart and the brain. The magnetic field inside the body forms the basis of obtaining the images of different body parts. This is done using a technique called magnetic resonance imaging (MRI). Analysis of these images helps in medical diagnosis. Electric motor. An electric motor is a rotating device that converts electrical energy to mechanical energy. An electric motor consists of a rectangular coil wrapped of insulated copper wire. The coil is placed between the two poles of a magnetic field such that the arm Abe and CD are perpendicular to the direction of the magnetic field. The ends of the coil are connected to the two halves P and Q of a split ring. The inner sides of these halves are insulated and attached to an axle. The external conducting edges of P and Q touch two conducting stationary brushes X and Y, respectively. Current in the coil wrap enters from the source battery through conducting brush X and flows back to the battery through brush Y. Notice that the current in arm A of the coil flows from A to B. In arm CD it flows from C to D, that is, opposite to the direction of current through arm A. On applying Fleming's left-hand rule for the direction of force on a current-carrying conductor in a magnetic field, we find that the force acting on arm A pushes it downwards while the force acting on arm CD pushes it upwards. Thus the coil and the axle O, mounted free to turn about an axis, rotate anti-clockwise. At half rotation, Q makes contact with the brush X and P with brush Y. Therefore the current in the coil gets reversed and flows along the path B. A device that reverses the direction of flow of current through a circuit is called a commutator. In electric motors, the split ring acts as a commutator. The reversal of current also reverses the direction of force acting on the two arms A and CD. Thus the arm A of the coil that was earlier pushed down is now pushed up and the arm CD previously pushed up is now pushed down. Therefore the coil and the axle rotate half a turn more in the same direction. The reversing of the current is repeated at each half rotation, giving rise to a continuous rotation of the coil and to the axle.